So yes, because in 2016, 5% was the parameter. And now we're saying in 2017, the interval is all less than 5%. So this interval right here, because it doesn't contain the value of 5%, and it's actually all lower than 5%, we can say that the value has changed. Does everybody understand that? And because that value has changed, or because 5% is not sitting inside of here, we're going to say that crime has actually did what? The breaking rate has actually did what? The breaking rate has actually decreased. So we're going to say, therefore, the rate has decreased. We're going to talk about these things called sample size calculations. And I'm going to use the example to try to bring you into this. And it says this, example 1. In response to the question, how do you judge a company? 84% said the most important way was how a company responded to a crisis. Y'all know who ITC is? We all know who ITC is, right?
A whole bunch of BS.
So how would you judge that company? Well, we're going to judge that company based off the way they responded to a crisis. They just had a crisis, right? So,
Yes.
They're like, yeah, send the kids to school.
yeah, right. 84% said the most important way was how a company responded to a crisis. If a follow-up study to estimate the population proportion of individuals who said that the most important way to judge a company was the way the company responded to a crisis, how many people would be needed to be 95% confident within the margin of error plus or minus 3%? So here's how this works now. I want to have a certain level of confidence, which we know that 95% confident means, what's the critical value for 95% confidence?
1.96.
Thank you so much. So we know that for this already, that Z star is equal to 1.96. And we did that a second ago and got this critical value using this right here. And then I want the margin of error to be what?
0.03.
So what does that mean? What do we call the margin of error there? Remember we call
Is
it?
that the solved?
That's the
after
actual
it's
part.
already
Yeah,
solved?
that's the part actually. So we'll call it E though. E is equal to 0.03. Everybody got that? Here's what I'm looking for. I want to know how many people do I need to survey? How many people do I need to survey? How many people will we need to survey to be within a 3% margin of error if I have a critical value of 1.96? And they gave me some information here. And they told me that the actual sample proportion or the population proportion was what? 84% said the most important way was how a company considered a crisis. So we know that P hat. We know that P hat is equal to what? 84, which makes Q hat what? 84 said the most important way was that, so the other 16% said it was some other way. 0.16. And here's how this works now. We're looking for how many people. What do we call how many people? What letter do you call that? N. We're looking for N. Thank you. We're looking for N. In order to find N, I have a formula. And the formula looks just like this, and it comes from the margin of error. The margin of error is equal to this, by the way. E is equal to Z star times the square root of P hat Q hat over N. That's the actual formula for that margin of error. Well, look what's involved in all that formula. I have an E, I have a Z star, I have P hat, Q hat, N. Look over here. What do I have? I have an E, I have a Z star, I have a P hat, a Q hat, and now I'm looking for what letter? N. So I can rearrange this formula now. And when I rearrange this formula for N, here's what I get. I get N is equal to,
Wait, why are you already doing that?
because I'm going to show you how. Because what we need to do, we need to solve the equation for N. We really need to solve this equation for N. And rearranging for N, you're going to get this. N is equal to P hat times Q hat. All of that is going to be, multiply that by Z star divided by E squared. This formula right here is called a sample size calculator. And it'll calculate the sample size of anything for you now. So here's how it works.
Let me do it.
Let's plug in what we know.
Let me do it.
Okay. We know that n is equal to, what's p hat?
0.84.
0.84. What's q hat?
0.16.
0.16. Times z star.
Times.
Yeah, we're going to multiply that times z star, which is 1.96 over e, which is 0.03. And then we got to square all that. So in our calculators, how do we do this? How do we do this in our calculators? Let's do it. What will we do first?
Is it 292?
I don't think that's right. Try it again. If you're doing it in your calculator, you're going to do this first. Do 1.96 first, and then divide that by 0.03. 1.96 divided by 0.03. And then you're going to take that value and do what to it? Square it. So we can do 1.96 divided by 0.03, get 65.333. Square that. You get 4,284.444, right? Now we multiply that number by what? 0.84 times 0.16. So multiply that number by 0.84 times 0.16. And I get this value right here. So my n is equal to,
Did you get 65?
yes. My n is equal to 573.7 people. What's the problem with 573.7 people? You can't be a 0.7 of a person, right? Is everybody saying that? So what should we do here? Round up or round down?
Round down.
We always round up. We're always going to go up.
573.
You want to be you want to err on the side of caution, and the err on the side of caution, you always have more people than what you actually need. So we're going to round up to 574. You always round this number up though. If it would have been 0.01, if it had been 573.01, guess what you would have did to that? Round up to 574 still, all right? So you always round up. Now, there's a problem with this formula. This formula right here assumes you know p hat and q hat. Most of the time when you do these surveys, you don't know p hat and q hat. You're estimating. You don't know what those values are. That's why you're doing this. So when we don't know the actual values, such as, look at example 2. In preparing a report on the economy, we need to estimate the percentage of businesses that plan to hire additional employees in the next 60 days. How many random selected employees must we contact in order to create an estimate in which we are 98% confident with a margin error of 5%? How is this problem different from this problem up here? Well, we have to find z star first. What's z star? Let's say define it at what level of confidence? Try it again. Define what level of confidence?
Oh, I don't know.
At 98% confidence. Let's draw the curve.
So that's what? 1 and 1,
Yeah,
99.
good. So 98 inside, it's 1% to this side, right?
So it's 2.22.
So that's inverse norm. 98 plus 1 is
99.
0.99. So I get a z star equal to,
2.33.
yeah, 2.326, right?
Yeah. Do it put all that or just 2.33?
Go 3 decimals. 2.326 is that value for z star. I know the margin of error E. What is E equal to here? They want us to be within what margin of error?
60?
5%. Margin of error is 5%. So how do you find the margin of error? So 5%, how do you write that as a decimal? 5% is a decimal. What is that? 0.05. Now, what's p hat and what's q hat? What is p hat here? Well, it has to be a percentage, so that's not a percentage. 60 is a percentage. What's the percentage for p hat? The sample proportion. So we don't know. They don't give us one. You understand that? So because they don't give us one, we need to come up with an estimate for it. And we're going to use the most conservative estimate possible, which means when you say conservative here, when you find this, then what's going to end up happening is you're going to get the biggest estimate possible. And it turns out that the biggest estimate possible occurs when p hat and q hat are the exact same numbers. And they're the exact same numbers when they're both 50%. So we get a new equation, which looks like this. The new equation is n is equal to. We call this when the prior estimate is unknown, or conservative estimate. If we don't know p hat and q hat, we say n is equal to 0.25. And that's because we're making this p hat value 0.5 and this q hat value 0.5. When you multiply 0.5 by 0.5, what do you get? 0.25. So you're going to make p hat 0.5, q hat 0.5 if you don't know, and just make them both a half. And you multiply this by z star over e squared. But you only do this when you don't know the p hat and the q hat. And here we don't know what p hat is. So because we don't know what p hat is, to find n, we need to use the conservative estimate. And so it works like this now. N is equal to 0.25 times 2.326 divided by 0.05 squared. What do we do first? Bless you. What do we do first? Bless you. 2.326 divided by 0.05 is 46.52. Square this, 2,164.1104, and then multiply that by 0.25. And I get this number right here, which is 541.03. 541.03. What do we do to this number, though? Round it up so you get what? 542. So I need to survey 542 when p hat is not known to be within that actual error estimate. But look at part B. Here's what we call it conservative. What if I do know p hat? Suppose in a previous survey that 14 out of 80 businesses responded saying they would hire them in the next 60 days. How many randomly selected employees must we now contact in order to create an estimate in which we are 95% confident with a margin of error of 5%? So this problem's different how? In this one we didn't know what? P hat. This one we know p hat is what though? P hat is now 14 out of how many? 80. 14 out of 80. The 60 is the number of days. 14 out of 80. So it's 14 divided by 80 is 0.175. And that means that q hat, how do I find q hat? 1 minus that. So 1 minus 0.175 is 0.825. Now, look here. And this one we did 98% confidence with the margin of error of 5%. Here we're still doing what? 98% confident with the margin of error of what? So that part's not going to change at all. Do you understand that? So it looks like this. N is equal to 0.175 times 0.825 times 2.326 divided by 0.05 squared. 2.326 divided by 0.05, and I square that value, and I get this. Same number I got a second ago, 2,164.1104. But now I'm going to multiply that by 0.175 times 0.825. And look what happens to your estimate for the number of people. You get what?
Where'd you get 825 from?
Because that's 1 minus 0.175. 1 minus this. If I do 1 minus, I get q hat. So that's 0.312, 0.3124, right? And we round that to what? 313. Look at the number of people now, though. We went from needing how many when it was unknown? When it was unknown, we needed how many people? 542 people. But when we know something about it, how many do we need now? 313. This is called conservative because when you don't know, you make it as big as possible. This is the value that makes it as big as possible. And you have the least amount of information about the population, though. Here now we have some information, and what happens to the actual sample size? It goes down to 313 because you're becoming more accurate because you know more information now, right?